Hello, let's do the Netflix puzzled Starstruck, Snippets, and Currents. Start with the easy Starstruck. It's called Game Tree. So in each row, each column, and each colored region, we're placing exactly one star. Stars also can't touch each other, even diagonally. So this two-cell region down here, very powerful. It removes the rest of the row, because there's a star in one of these two, and the row can only have one star. But also, wherever this star is, it'll touch one of these two. It'll touch both of these, always. And so these two are out as well. Now this orange is going to remove the rest of the column, and also this one, because it always touches all of orange. That leaves two left in green. That removes the row, and then also this one. But also remove the two above if they existed. And now this is down to these three. I could fiddle around with this, but let me just say what I was going to do. One of these three, this touches all three. But if we look at this row, it is only brown. So wherever the star goes in this row, it's going to also be in brown. There's only one star in brown, so the rest of brown is out. All right, and that saves us from a few formation-like deductions. Okay, so indigo here is in these two columns only, and blue is in these two columns only. So indigo is going to put a star in these two columns. Blue is going to put a star in these two columns. So the rest of the columns can't be in. It would be a third star in two columns, which you can't do. That leaves one left in yellow. That's our blue. That's our indigo. That's orange. That's red. And that's green. And that's brown. And whenever the easy feels like it could have been a hard, I get worried that the hard is extremely hard. But let's see. We are getting towards the end of the week. Corner cases. All right. So we have a potential X-wing. Let's see if there's any. Let's actually definitely apply any formations we have first and the other easy deductions. This sees all. Whoa, whoa, whoa! Sometimes I accidentally click. This sees olive green. It touches olive green even, so that's not in. Huh. So, do I use the potential X-wing now? I don't even know if it's usable, but let's analyze it. So, if we were to pretend that this wasn't in, and this wasn't in, and these two weren't in. Sorry, not that one. And this wasn't in. We have to pretend that all of these aren't in. But what that would do is that would force what they call an X-wing. I would call it like a rectangle. We can draw this square in this case, but squares are rectangles. We can draw this rectangle. And what we've discovered is that this is two columns and two rows, which means we have a maximum of 4 stars. And if these are not in, if these are not stars, then what we've discovered is that we have completely covered 4 regions: green, indigo, gray, and blue. And so if we've completely covered 4 regions, that means those regions cannot escape out of those rows and columns, making 4 stars. And so the consequence of that is that, first of all, we cannot put a star in the corners where they overlap, because then we wouldn't have 4 stars in 2 rows, 2 columns. Because if you put it in the overlap, that's the star for both the row and the column. And as a result, we'd only have 3 stars, or 2 if we did 2 corners. So we can't do the corners, but also we can't do any other regions in these rows and columns, because that would be a 5th star in 2 rows, 2 columns. So we'd be able to eliminate all those, but only if these are all excluded. So either we're going to have to exclude these in some other way, or we can, if there's any deduction that's shared, I don't think there is, then we could use that. But that's something to think about. It's sometimes a technique that's helpful. Oftentimes the puzzle's built around that technique. I do have something easier here, which is that the right 4 columns. I'm being bothered by Gemini. All right, the right 4 columns are going to have 4 stars in them, and I know that green's going to put one there. So is yellow. So is blue, and so is orange. That is our 4 stars. So brown cannot put a star there because that would be a 5th star. And now brown and red line up in these 2 columns, removing these. So we're slowly getting rid of some of these, but What do we got here? Oh, we have the bottom. No, not quite the bottom 4. Bottom 5. No. Huh. Do we have this? Oh, this is the other side of the coin here. I think. So we know there's 4 stars here. One is definitely in indigo. One is definitely in gray. But where do the other 2 go? We need 2 more colors. Well, we have orange and we have brown and we have red available. Okay, that's not helpful at all. That tells us there's a star 1 there. Okay, I missed that this column had... Basically what I was about to try to prove is that this column had only one place to place it, but that's just not true. It's here or here. So this is an L shape. That does mean this isn't in, because it shares a column with all these and touches this one. Is that enough to do anything? I don't think so. Okay. 3. Yeah, I mean, we know these line up. We know these 2 line up, and we know these 4 line up. Let me rows. Let's look at rows. It feels like a lineup thing, but I don't know if there's something else. So the outliers that aren't part of the X-wing are these 3 now, 2 of which share a column. I don't have anything good to do with that. I'm not even sure how much the X-wing helps in this case, but I mean, it's called corner cases. It makes me think, hey, look at the corners, but maybe that's a red herring. This is a very powerful star right here. It gets rid of all of these. It would leave only 2 places. It also gets rid of these. It places this one, which gets rid of that. So actually, it gets rid of all of green. Oh, interesting. Is there a lineup that I can use for that, or is that... I'm not sure if that can be visualized with a lineup. How can I see that in a better way? It really has to do with touching. And when it has to do with touching, it's a lot harder. But basically what we said is, hey, I guess in these 4, let's do the 4. Maybe the 4 is better. We already know that these line up into these 4 columns, but does it have to do with this column alone, or I'm trying to see if there's a more generic deduction that could get us more out of this, but because just eliminating this doesn't seem very powerful, but I mean, we could do it. But so this forced this, and the combination of the 2 gets rid of both of these, which then forces yellow to be over here and green to be over here. It's no good. So it has something to do with this column, probably. So the only way we place a star here is if we also place a star here. Okay, maybe there's another way to put it, which is that wherever we put the star here, if we put the star in this blue, obviously this blue's not in because it's in the same region. If we put the star here, then that gets rid of this one, which forces a star here, and so this blue is still out. And then obviously if we put a star here, it shares a row. So we can use that this column, no matter what, eliminates that star. One of them has to go through the medium of this guy, but it's not very hard to see, or this one goes through there. But so we can eliminate this one. I'm trying to whittle away the ones that are peeking out of our X-wing. I don't know if that's the way to go, but that's what I'm doing right now. Because we're getting close. We're down to just these 2 for our X-wing. So maybe something's going on with orange, where if we place here, it gets rid of a lot of orange. and that, and that. And so now orange and gray line up. Well, we already know. I mean, the rest of indigo's out, so it doesn't matter. Oops, not that orange. I don't know. It's like, that's out. Well, I guess that places this. That seems powerful. And it places that. And it places that. And then so it places this orange. This is a huge look ahead, but I'm trying to do what I did last time, which is say, hey, if we know this isn't true, maybe there's a cleaner way to see that. And it probably has to do with the 2 in this column, maybe. But I haven't actually proved that this doesn't work. I might be finding the solution right now. Oh no! See, now orange is broken. So that's nasty. But this gets rid of this orange, and then these point down to this orange, or the other way around, or green is broken. So I wonder if there's something we can just say directly about this column now that we know this isn't in, right? Because we know that this column has 2 places. This one just directly eliminates it. So all I have to prove is that this one also eliminates it. And it's very powerful. It gets rid of these 3, which places this one. It gets rid of all of these. But does it do enough? I mean, it gets rid of all of this too. And that. And these. And these. It's still a lot of look ahead, and I haven't done it yet. Maybe I have to prove this is out first. Is that more helpful? I don't even know if this is true. I'm just hoping it's an X-wing. So we can take a look. I mean, that places that. Rest of green is out. Blue is over here, so this is our yellow. Get rid of those. This isn't broken yet. Gives us the gray. We still need a blue. Oh, red's down there. So blue. Oh, yeah, blue is broken. So okay, so there is a way to prove through huge look ahead that this one's not true and this one's not true, which would give us our X-wing. So I just need to find a more elegant way to prove that. So do these 3 have to do with that in any way? I mean, we know that either of these gets rid of that one, which places that one, and it does get rid of that one. So that's the easy case. It's this case that we have to prove gets rid of that one. So it eliminates all these. And now these are all gone, because blue is in this column now. Oh, and that's out. So blue's in one of these 2, and so that's placed, which is not helpful for eliminating this guy. Basically, we're down to these 2 in green, both of which look fairly viable. So we might have to use stuff over here. No, we've broken down here. We haven't broken green. We've broken down here, where red has nowhere now. Oh boy. So I haven't proven that this green's out. I've just proven that this doesn't work at all. I mean, is that helpful that this doesn't work? I mean, it eliminates these 2 reds, right? Which is going to force this blue. And that clearly gets rid of all of gray, right? Red gets rid of these, and then this blue gets rid of that. So I'm gonna eliminate this one. That's all I need, because now one of these 2 is in, which eliminates that one. That places this, and now I've gotten rid of that guy. Nasty though. Nasty look aheads. This column is going to be yellow or green. So do we try to get rid of this one now? Or do we have something better? Actually, we have something better, don't we? No, we don't. I mean, no, I'm not seeing it. One of these two. Um, so I don't know if this is helpful at all, but we know that this has a star and this has a star. And it may not be super obvious, but we need a star in one of these two. And whichever star that ends up in, it's going to force the star in red to be in the other one. So one of these is definitely a star, and one of these is a star. And since one of these is a star, that gets rid of the rest of gray. But can I, and I think that was true even with that not eliminated, because it's just this square here. So even if we didn't use this look ahead, which, I mean, I'm going to keep using it, but this square here can only have one star, and then this rectangle here can only have one star because it's in the same row. And we know we need two stars in here because we need one in red and we need one in this column. And so as a result, there's a star in one of these three, which eliminates all of these. That places gray. Okay, and now in this column, this is the only one. I'm not going to undo back to this, but that might have been a better deduction to have used rather than this one. But what did that do for me? It did this column. This column's placed in blue, and that gives us this guy. Okay, and that gives us brown. Yellow's in one of these two, so that's out. Orange is in one of these three, which eliminates this one that sees all of them. And so this is placed, and that gives us this orange. That gives us this green and this yellow. And we've actually finished. Okay. I am kind of curious, but I spent 15 minutes on this already. But I think that deduction would have probably done a big enough cascade that it didn't need this other deduction. Anyway. All right, let's do the snippets. It's called work in progress. All right, so it's like a mannequin. Do we have an in? It's all one color, unfortunately, so I can't use colors today. This is 8. 8 could be 2 by 4. It's not going to be a... it could be just a vertical, using the whole vertical. I don't think we can do 2 by 4, though. Oh, no, we could do this 2 by 4. So we're always using these at the very least, and that affects this 6 quite a bit. 6 is always using these. So what if the 6 did this, right? Then this would have to be taken. I mean, the 8 would do this, and now this has nowhere to go, right? So the 6 is definitely not doing that. So it all has to do with, okay, if we do this 8, then we have to do this 6. No, that's 7 long. Yeah, there's no way the 8 does that. So I think the 8 has to do this. I think that's its only option. Unless, oh, we could do 8 like, we could actually do 8 like, oh, come on. We could do 8 like this. And then 6 like that. And then 4 like that. I wonder if that's what we're doing. Nope, this 6 is broken. So I can't just vibe that, I guess. It seemed nice. But yeah, if 8 did this, does that just break over here somehow? Like without the other stuff happening? I think I've been doing forced moves. This 6 breaks. Let me just double check that all of these were exactly forced moves. If I do this, the 3 has nowhere to go but do that. The 4 has nowhere to go but do that. This has to be taken by the 6. This has to be taken by the 3, and now this 6 has nothing to do. Okay, so we're not doing the 8 like this. Now, could we do the 8 like this? That would be the 3. I'm doing forced moves only. What's the 6 doing? This breaks the 4. So the 4 is either doing this or, let's see, what takes this one? This one's taken by the 4, for sure. Now the 4 could do this. I think this 6 would have to do this in this case, and then this would have to be taken by our 4, but it can't be. That is not viable. Okay. Can the 6 do anything else? No. Well, it could do this, actually. The 4 could do that. 2. This is not takeable. Okay, I gotta find some logic that's not gonna get me into a hole. So who takes this one? It's not the 6. It could be the 3. It could be the 8. But we proved this 8 doesn't work. So it's got to be the 3. Okay, that's at least something. Now this could be taken by the 3 or by the 4. Feels like it's the 4, but I don't know for sure. So we could do 3, 4. Do we have to worry about this 6? Like, are these 6s just doing that? So we're not isolating this. This is 1, 2, 3, 4, 5, 6, 7 cells. We can't do a 2, 2, and a 4, which has 8 that way. So these top 2 rows, one of them leaks out at least. These clues do not cover the top 2 rows. So something in this row is used by the top clues at least. And as a result, does that mean that we can't do that? We could do that. So what's the restriction here? This 4 forces this 6 or this 6. I don't know. This could be taken by the 4 or the 3. Do we just check both cases? What's our in? Like, okay, maybe we can prove this 2 doesn't go down, because that makes this 4 do this. That makes this taken by the 6. This could be taken. Yeah, I think this is taken by the 6, but it could be taken by the 4. But then does that break the 6? The 6 would have to do this, and the 8's super broken. So I think this is taken by the 6. I think the 8, because that. But now the 3 and 4 are broken. But the 8 doesn't have anywhere else to do. So yeah, we're not doing 7 and 6. So I think that proves it's broken. We're not doing the 4. That the 8 is. In fact, from here, the 8 is doing that. Now if we just count 1, 2, 3, 4, 5, 10, 12, this doesn't add to 12. It adds to 13. So that's no good. So that proves the 2 does the neck. Pretty sure. I hope so. Something else we can disprove? 6 going all the way down, maybe? 8 can't go up and down. So the 8's doing this. 8, 9, 10. Where this is way more than 10. So the 8 can't do that. So the 8 would do this. And then now the 6 can't do anything. Again, the 6 would have to do this, and then the 8 can't do anything. Okay. So this 6 doesn't go straight down. Does the 6 do this? This would be taken by the 4. The 8 still would have to do this, but now obviously the 6 and 3 are broken. So the 6 doesn't do that. Does the 6 do this? Wait, I already tried that. Does the 6 do this? This 6 would take here. This 8 would take like this. We can't do 7 and 6, so it would do this. This would be the 4. This would be the 3. This would be a 6. That's 3. That's 2. That's 4. Okay, finally found one that works. I don't know. I don't know if there was a good logical solve for that one. Seemed tough. What's the average solve time? 149? I don't know. What was I missing? The average is 149. Okay, well, let's do currents. It's called train ride. So the 6 is the end. There's only one way into it. So we're going to be ending like that. And this is not used. We always use the corners. So this 4 is going to go around this corner. The 5 is going to use this corner. So we don't know if the 4 goes down and then the 5 goes up and around. It looks like that's viable. Or if the 4 goes right and then the 5 comes down. That looks viable as well. The 3 can't get to the 4 unless it goes directly there. Because the 4... Yeah, if the 4 did this, the 3 isn't getting to it. In fact, it makes a little loop. So that's enough to say, hey, the 4 doesn't go right because now this can't go down. It goes right, and now we have a little loop that we're not allowed to do. So this doesn't happen. So the 4 goes down to the 3. Now this could be taken downward. Yeah, we don't know. We know this goes in this direction, which means this goes in this direction, and this goes in this direction. So this has to make it to the 5. But we already knew that. It's going to the 5. Can the 1 make it to the 2? Okay, well, so yeah. So if the 1 did this, that's a mini loop. We're not allowed to do that. So the 1 does go straight to the 2, which makes perfect sense. The 2 goes down or right. But who takes this one? I don't know. We could go straight through. But okay, if this went straight through, then what's the 2 doing? The 2 has to make it to the 3 somehow. How's it going to do that? It's not doing it through the 5. So I think it's going to do some... Okay, if it went like this, then now this has nothing to take it. So it's not doing that. So it's doing... Well, then what's this doing? Hold on. This can't go to the 1. The 1 is the start. So this continues down. And this can't go to the 2, so it continues down. So I think we're going 5 to... Well, but then what's the 2 doing? Hold on. I've gotten myself into a corner here. The 2 clearly in this case goes down, but now it can't go left because that would make it to the 6. But the 2's not making it to the 3 this way. That's definitely true. Like this goes to the 5. So the 5 can make it to the 6, but what's the 2 doing? Okay, so let me start over because I feel like I made a mistake somewhere. This corner's always taken. Let's do the corners first. This corner's taken. This corner's taken. The 6 can't go left, can't go right, can't go up, can't go right because that's a 2. So it's going down. The 1 can't go... the 1 only goes in one direction out. No, it doesn't have 2 ways out. That's what it is. We do this. Yeah. This is it. All right, that was actually easy once I figured out. I had 1 have 2 exits, which isn't what we need. Okay, that was the only issue. Probably took much longer than average on that one too. Average of 30 seconds. All right. Well, that's it for today. How'd you do?